Hello everyone, welcome back to a new episode of Advent of Code. Before we start on day, what is today? Day 9? I wanted to show you guys something that I did just back in day 7, the last int code problem. Nothing like amazing or anything, but remember I talked about how the transformation we were doing in to like keep track of all the computers that were like when we wanted to run 5 computers in sequence, right? I kind of had to do a lot of work to manually track both the current accumulator and the here. In fact, let's whatever, and the memory states of all the computers that had run so far. And I remarked that actually, like, what we're doing is kind of an operation in the writer monad, and I didn't want to do that at the time, but I did want to see what it ended up looking like. So, needed a bunch of imports here. The monad transformers for writer and accept, because like we were inside the either monad already, which is its transformer version is called accept. So to combine that with writing, like an operation, I wanted to fold an operation that could fail if we got a left value, and also could write some results in addition to what the fold is going to return. So we wanted to run it inside of both writer and accept. So some small changes had to happen to this run feedback program to accommodate the new type of run one step. It used to take a value and a list of computers and return either a string or a pair of list of computer and value, and like that's a little bit of a mouthful. Now it returns something that's equivalent, a writer t where the value you're writing is a list of computers, and the monad that is wrapped inside of is the exception monad, where the exception you're allowed to throw is a string, and the monadic value that you write is a value. So you have to do a little bit of stuff up here, right? You have to run until done takes it returns an accept, but we're in like an either context here. Maybe it actually would have been better to change run feedback to also be in the either monad, and then I wouldn't, or in the accept monad, then I wouldn't need this. That might be nice actually, but whatever, they're both fine. Run writer t returns its arguments in the opposite order, so I flipped these. But the important stuff is like what happened. Hello, can I get my cursor back, please? There we go. Is what happened in run one step. It's like, it's not substantially shorter. In fact, I think it's about the same length, right? Like, yeah, they're each 10 lines. But there's a lot less kind of manual dealing with. I mean, honestly, it's even like more tokens this way, right? Probably, I think. But the tokens are like simpler. It's easier to tell that I haven't made a mistake. The manual handling of tuples in the previous version is kind of a pain, and here with the like, when we want to add a new computer to the return value of computers that still need to be run, we just call tell, and like we do that when C is running instead of this like this thing here, right? I'm still a little bit sad about the fact that you need a case on this like this case on outputs is a bit like, but you know, whatever. It's fine. And so like then the rest of the thing is pretty much unchanged. I just wanted to show you guys like what it looks like, and to prove that yes, indeed, I can at least sort of use monad transformers. All right, so that's that. Now on to today's problem, day 9. Day 9, sensor boost. You've just said goodbye to the rebooted rover and left Mars when you receive a faint distress signal coming from the asteroid belt. It must be the Ceres monitoring station. In order to lock onto the signal, you'll need to boost your system. The elves sent up the latest boot program, Basic Operation of System Test. While boost, which is your puzzle input, is capable of boosting your computers for tenuous safety reasons, it refuses to do so until the computer it runs on passes some checks to demonstrate it is a complete int code computer. Complete. Maybe we're done. Who knows? Your existing int code computer is missing one key feature. It needs support for parameters in relative mode. Parameters in mode 2, relative mode, behave very similarly to parameters in position mode. The parameter is interpreted as a position. Like position mode, parameters in relative mode can be read from or written to. The important difference is that relative parameters don't count from address 0. Instead, they count from a value called the relative base, which starts at 0. The address a relative mode parameter refers to is itself... Okay, so the number that is there, okay. Plus the current relative base. When the relative base is 0, it acts just like a position parameter. Otherwise, it's based on the relative base. The relative base is modified with the relative base offset instruction, opcode 9. Adjust the relative base by the value of its only parameter. Interesting. Sorry, I was just reading the next paragraph, not saying it out loud. Because I just thought maybe we were done. So your encode computer will also need a few other capabilities. The computer's available memory should be much larger than the initial program. Memory beyond the initial program starts with the value 0 and can be read or written like any other memory. But negative is no good. The computer should have support for large numbers. Some instructions near the beginning of the boost program will verify this capability. Okay, so... all my work of using vectors instead of int maps was proven foolish because an int map is perfect for this, right? All this slicing and all the cool stuff I was doing, like, does not extend to arbitrarily resizing and being sparse. Changing int to integer should be really easy. We just have one type alias somewhere that says int and it can say integer instead. And then we run it'll output a single value. Great. So our input is just the program. Yeah, nothing fancy there. All right, it seems okay. Day 9, right? Yeah, I adjusted my input script to put it in the right directory automatically, so that's nice. So we need to grab the latest encode, which happily I have right here. Go put it in 9. And let's see. All the places where we use vector are going to need to change. Address could probably be int, but I guess... No, we're reading values from the encode program itself, whose memory is integers, and so, okay. And we can't have vectors instead. We need import qualified data.intMap as, let's say, I. And it's just an i.map, i.intmap. I always forget Haskell intmap. Intmap lazy. It is called intmap. Okay. And so we just look for all the places where we called like v dot something, right? And just say like I, probably. Or yeah. Okay, so what we were doing is slicing the next several parameters. But that's no good. Okay, so what are the things you can do to an int map? They're basically the same as map, but I don't know what they are. Query, I guess, is the thing we're looking for, right? I mean, submap is... No, this is like not... Okay. So there's conversions in principle, like, yeah, but that's not what we want. So I think we just want a query that like looks up multiple elements. Yeah. We'll just map with like lookup and get a list back. Map I dot wait, what am I even using maps for? Oh, the opcodes, got it. I dot, not lookup, because we're using the operation that like always succeeds. We're sort of cheating here. So map, looking up in the memory, I is the IP, so from I plus 1 to I plus numparams operation minus 1? No, plus 1. Minus 1? Maybe leave it alone. Because if there were one parameter, we would look at I plus 1 all the way up to I plus 1 and no further. Yeah, so this is correct. Okay, so we've successfully looked up the parameters there. And we just need to redefine, to change read. Oh, I'm so pleased that I already extracted this out. It's got the wrong type now. Oh, I need split apparently. Forgot about, we were using that for something. What the heck do we use split for? What? Oh, for reading for parsing a program. I see. Do I have any other remaining REPLs? I guess I do. So apparently we're going to need to build here to get our dependencies down, our configured for Cabal to be happy. Is that enough to make Emacs happy, or do I have to actually restart it? Yeah. Well, actually, it's fine now. It's just mad about the things I am aware I have not yet finished. This is easy. No, I. Now we need to figure out how to write to an map. Oh, actually, we need to also change read to handle. It shouldn't use I.lookup. In fact, the other place we used I.lookup is incorrect. We need to, if there's nothing there, we should return a 0. So the function for that is find with default or something, I imagine. Yeah. No, it doesn't want things in that order. It wants I dot find with default of first the default value, which is 0. Then the key, and then the map. I mean, I could define a local function that's just like this, you know, but why, right? It's like not really saving us anything, and this way is nice and explicit. Okay, and so to write to init maps, there's a bunch of functions. Insert inserts a new value and it's updated. So that's fine, actually. Ah, yeah, so we want like, we're using a lazy int map, so I guess we should use fold R. Is it just fold R of like uncurry I dot insert? Yeah. That will insert all of these things, and we take the two parameters by currying. Nice. How do I look at the next error? Okay, v.fromList. Yeah, that's true. So you want I.fromList zip. Yeah, we've done this before. What are you mad about? Oh, wait. What? Oh, program is a list of ints. Well, now it has to be a list of integers. Okay, that's fine. And now suddenly you're mad about this? I see. An int map only has ints for keys. Yeah, I guess there is sort of a conflict there, right? We're saying we need a map that can have, like, our memory can have very large values in it, so we need integers, but each of those need to be treatable as addresses in the program, so we really can't use an int map. I mean, okay, I guess it's probably not likely they're going to give us a 4 billion as, like, a key, but, like, you know, why not? Maybe they will, so let's just not use an int map, we'll use a regular map. And we'll key it by integer, and it's just, like, not that efficient, but it's a map from value to value. Take that. And, like, pretty much everywhere we use I dot, we can probably just replace it with M, and that's, like, totally fine. Looks good. That one's also fine, right? What's wrong with this? What's wrong with these? Oh, well, these take ints. But we need integers now. Integer singular. Couldn't match type. Okay, what's the type of m.insert? Why won't you tell me? Sorry, just having trouble typing into... Okay, so data map lazy, insert, takes a key and a value and a map. And foldr takes the accumulator second. No. Well, yes. It takes the accumulator... Oh, sorry, you guys can't see the type signature. I'm just thinking, like, it must be, like, I need to flip something here, and then it's all fine. So foldr takes first its function, which we're giving. Then it takes its accumulator, and then it takes the list. So we do indeed need to flip this. There we go. So we need to first apply this argument, and then flip the remaining two. That's why this this works, which is the same as what the $sign is doing. But this, which is what you get without the $sign, doesn't work. So, okay. Wait, it was working a minute ago, wasn't it? Maybe I was just incorrect when it briefly looked like it was compiling. I got confused. Oh no, I put the $sign in the wrong place. Okay. No, that doesn't make any sense. There we go. Okay. Okay, well, you don't have any more references to int map or vector in here, so that's nice. And then I think all that's left is to implement this new opcode, which seems very simple. We need to make a few changes. First, let's put into our computer the, what do they call it? Relative offset? Relative base, I guess, is an address. Okay, the operations might as well be keyed by integer as well, I guess. That's fair. Param count is an int now. Whatever, we'll make it. Okay, maybe I shouldn't just like start turning ints to integers. I should think about what's going on here. So, I mean, I could just turn them all to integers and it would be fine. But really, these should be ints, right? I don't know. But the problem is we need to like treat them as integers later anyway. Whatever. Let's just put some integers in there and see what happens. Map 1 dot. Oh, I searched for I dot, didn't find it. Okay, yeah, that's fair. Is it just M then? Do I have any ints left? Int to mode? No. Why is everything going wrong? Oh, have I just not reloaded yet? No. Well, okay, this, I said it was an integer. Man, why is all this stuff lighting up all of a sudden? Couldn't match type int with integer. Expected an address, got an int. Where'd the int come from? Advance. Where are you getting the idea that this should be an integer? Or an int, rather. There it is. So each operation has an integer number of parameters, even though, like, really... Oh no, that's correct. This should be a value, shouldn't it? I guess. I was thinking it makes sense for it to be an int because I'm not ready to call it either an offset or an address, or like an immediate value. But it needs to be of the same type as all the other values, and so calling it value is more accurate. Computer needs another argument now, which is, I think, the last one. And in fact, I feel like somewhere I should this 0 is like a magic number, right? Somewhere I should say, like, this is the default relative base. But I've also got two other zeros here that mean totally different things. This one is starting address. This one is like, I don't actually even know the initial IP. Yeah, all right, we'll just leave all the zeros in here. It's bad engineering. All right. I mean, Pred, Shadows, Prelude, who cares, right? Actually, I could. I could hide that and then it's like, fine. This case is still non-exhaustive, but it's easy now that we're returning an either to like fix that, right? Okay, I mean, sure. All right, so we have this new opcode finally, which is, what do they call it? Relative base offset. And it's offset 9, it takes one parameter. Right? Adjusts it by the value of its only parameter. Increases or decreases by. Got it. So now we just need to handle that. By the way, something these advanced IP2 and so on, it would be nice to factor that out so each instruction is not responsible for it increasing its own IP. The jumps need to be, but everything else doesn't have to. It would be nice if like the other cases could just do nothing and jump like return some special value saying here's what the new value should, here's what the new IP should be. One way to do that would be to return, like to have an operation return either a just read the next instruction or a like here's what the new IP should be. But even then, like all the other cases have to be changed a little bit to say, oh, by the way, don't do anything funny. So I think I might as well just like advanced IP, remove the parameter, and then advanced IP, advanced IP is not defined locally, it's out here, which is fine. It just means that I was planning to like close over the operation to know the number of parameters, right? So we'll just say advance. And advance will be responsible both for F mapping and figuring out the right number of instructions to skip. And let's see. Advance of C equals advance fmap. Advance equals fmap advance IP of the number of parameters that the op has. Where the heck is that? An operation numparam. So I can just write numparams op. Okay. There. Seems fine. So now we just have this new instruction to write. Relative base offset, advance base params of, I guess this is how we're doing things, param C, where relative base equals relative base of C plus read param mem. Why is this lighting up? Oh, I didn't close the brace. All right. Seems fine. So what are we supposed to... What's the input? Run it in test mode by providing it the value 1. Okay. So let's go. What did I do in like day 7 or something? Like what did my main look like? Okay, that's a reasonable looking per pair, I guess. Import int code, and our input is a program. That seems correct. Oh, I could have taken away the bool import once I made the change to... All right, whatever though, right? And now, well, it's pretty simple, isn't it? Input, we just need to run the program, right? How do you run an encode program? Run to completion, right? Either string integer. Maybe I really should lift encode stuff into being monadic so that I would have an accept t string integer. Just seems nicer. Equals like... You know what? I should write a new function here. Input is a function from value to computer. Input x c equals c, where inputs equals inputs of c with x const onto the front. Then I can say part 1 equals run to completion input x. Oh, I have to load this. Why are you mad about input? Oh, I edited day 7 instead of, whoops. This is day 9. Input. Oh, okay. What I had written was actually correct, I think. No. All right, fine. Let's write it up by hand. I can't figure out the stupid. Oh, it's not just. Oh, I'm so dumb. Input 0. And we need to fmap outputs. What's wrong with fmap? I mean, input 0 So we have a computer left. Then we run it to completion. We have either a string or a computer. So we want to fmap outputs into that. That seems about right. Couldn't match list of integer with computer. Ah. So I have a function from input to something. And I'm supposed to have... I have a function from computer. Oh. I see. I didn't ever call make computer. Make computer, it takes a memory. Wait, so what's parse encode program do? What the hell is make computer? Does it like want inputs or something? It wants a program, which is a memory, and a list of input values. I forgot I had that lying around. Who knew? So make computer wants a memory, which is like the program. Flip make computer 0 parse. I'm still getting everything wrong. My input is I wrote that my input is a program, but my input, I wanted it to be a computer. Okay, there we go. All right. Unknown opcode 63. At offset 3. I mean, let's look real quick at our input, and I assume it won't have something crazy at offset 3. Oh, it does. Okay. So what's this first operation then? Wait. Oh, the input is supposed to be 1, not 0. Okay. Yeah, what the heck is 1102? 02 is like multiply, isn't it? Storing the result. So 1102 is a multiply. Both of them in immediate mode. So it says multiply these two gigantic numbers and store the result to address 63. Ah. So I messed up when I factored out the advanced IP. We have to skip over the instruction itself as well as the parameters. Come on. I'm still not very good at managing my... Oh, I need... What? Main not in scope? Oh, when you load a file, it like changes the context the REPL thinks you're in. I wish that the prompt here said something about what you're in. Illegal parameter mode. You're right. I didn't implement that either. What a dummy. Okay. So the only place to update that here is here, read of a relative. It's just called relative, right? Relative base, I called it. Okay. Oh no, Reed needs a computer now. Aww. Fine. Right, it's just called memory. Yeah. Fine with def 0 a plus relative base c, like so. And now all these reads need the computer instead. I don't totally trust myself to do a find replace there. So am I actually using the memory at all anymore? Yeah, I don't need this. Yeah, and Acelint is telling me so. That's nice. I'm a little bit unhappy about Reed taking the entire computer in now, but okay, whatever. Illegal parameter mode. Oh, I didn't add a clause to parsing parameter modes, I suppose. Right, I guess I didn't even okay, yeah. Position, mode 2 is relative mode, okay. Good. Invalid input. What does that code come from? So we're being told to input something, and there were 2 inputs. Which is fine, although there shouldn't be, right? Because we only gave it 1 input. Yeah, something is going on with our inputs, because there shouldn't be 2 of them. It found an input in relative base? Oh, wait, does that make sense? No, I think we were told that inputs would always be in offset mode? Or position mode? Because it's not really a parameter, so to speak, right? So, but something is still going wrong with the inputs, because we only ever should have put 1 input in there, right? Make computer takes a program and a list of values, which is the inputs, and we just pass those along. And in main, so let's prepare of, I don't know, when of the inputs from the problem. Perpapri, I see. So it's a memory. It's got one input. It's running. This all looks correct. And what happens with main? I mean, we can print the whole program when we're doing this, I guess. The whole computer, like, why not? It'll probably be pretty hard to get anything useful out of it, but at least I'll see, like, what position it's at and stuff. Yeah, so it's quite a mess. But somehow inputs became 0 and 1, which is just, like, impossible. That can never happen. Our instruction pointer is 25. And it's being given a relative input. Right, that's 03, which I believe is input in immediate mode. Just double check. Int mode, yeah, 2 is relative base. And operation 3 is input. So is that actually in our input, or did it get like, there's a 203 here, right? And like right before it is a 209 and a 3, yeah. So the problem may be that, like, I don't understand how, like, they sprung this concept of relative inputs on me, but there's like multiple other problems here, right? Which is that, like, there's too many inputs, right? That's the biggest one. The second problem is that somehow it gets to running this instruction that it's not supposed to run. Maybe it was supposed to have been overwritten or something, but I think we should figure out what's happening to the input, because that's like the most fundamental issue, is that like somehow our input is getting messed up. So let's say like let's say we do read file of input.txt, and then we like prepare the result of that, and then run, what do I call it, tick or something? Tick? It is tick. Oh, but tick turns either a string or computer, so it's actually more like this. Yeah, so we can see what it is after a single step. It has a single input. That's correct, right? And the IP is 4. What the heck is the monadic composition operator? It's this nonsense, isn't it? Yeah. So now if we run it 2 steps, we see it's at IP8 and it has 1 instruction. We run it 3 steps. I know this is like terribly primitive. There's still just 1 input. Still just 1 input. This is all like perfectly cromulent here. Uh-huh. 21. 23. We're almost at where the problem arose, and there's still just this 1 input. 25. There's still just 1 input. We're still at IP25? Wait a minute, that doesn't seem right. Were we just at IP25 twice? We were. Okay, something funny happened here. We didn't move forward maybe after the new instruction we implemented? Yeah, that must be it. No? Looks good. We read a single parameter. And we know it's a single parameter because the case would have failed otherwise. Let me just confirm that, like, oops, that if I run tick again, it's like still gonna be stuck on address 25 for some crazy reason. Yeah. What? All right, so let's like back off a couple steps. The first time we got to 25. What it's now about to run is 203. I mean, that's an input in relative base mode. What? That's no, it's not. Yeah, it is. 3 is input. And 2 is relative base operations. Okay, let's try running some of the test programs that they gave us, I suppose. Wow, int code Quine, really? Well, let's run this one. It's very simple. Run to completion of prepare this. Is that all? Like, I've forgotten what steps are in. input 0 to it, right? Oh, actually it says it doesn't take any inputs, so this should be okay. Gotta keep going back to the scratch buffer. Its outputs are a single large number, and it didn't read its input. So if I look at this, I see that it's a 2 is multiplication, I think. Yeah. To address 7 in immediate mode for both parameters. So we write to address 7, which is past the end of the memory, I suppose. Yeah, it's here. And then we do 4, which is an output of address 7. And then we halt. So that is exactly the output you should expect to get. I guess let's try running their like thing that's supposed to be a quine. Like, maybe it'll be interesting somehow. We get as output not a copy of itself. Right? Something's wrong here. Or wait, is it right? No, because we gave it a 109 and it output a 0. Like, it's all this is completely wrong. There's nothing right about this, I think. Oh wait, no, the outputs are in backwards order. So it's outputting 109, then 1, then 204. So this all looks fine, all the way up to 99. Yeah. So this is correct also. Where on earth did that extra input come from? I mean, I guess we can find out, right? We can say prepare. Oh. So first problem is prepare. This is just a problem in our like little testing, is that we don't give it the input. Oh my god, did I leave the input at 0? I totally did, and it's supposed to be 1. I remember saying that out loud, and I thought I fixed it. Let's try running main here just to see what happens. Did that somehow fix the problem? Oh my god, it did. Didn't produce any outputs, though. Just made 2 inputs instead. What? Oh, I see. Make computer and part 1 are both giving it an input. That's why there were 2 inputs. Well, that was an easy one to fix. But I didn't get any outputs, did I? Yeah. It says it's running. Why did I get something returned? Invalid input. Okay, at IP value 25. You know what would be useful is a disassembler, right? But I just want to like, I don't know. Tell you what, I could implement support for relative base for input, even though like it's clearly illegal according to the spec. And we can see if that fixes the problem. And if so, then like I'll go read the spec more carefully. You know what? Really, read and write shouldn't be the things that know about parameter modes. There should be something that translates parameters, right? Make absolute takes well, but then all these reads are awkward, right? let's just handle input for now. Where pause equal case mode of pause relative base, then it's case mode. Ah, this is circular. Should be param. Well, you know what? I can just lift this out into no, I can't. Invalid input parameter load. And I'll just like put the whole like C? No. Oh, okay. Now the problem is that I need to be able to fail from here, right? Okay, forget it. I'm just not going to handle that case. And if it's inexhaustive, then too bad. Non-exhaustive patterns in case. Okay, you got me. Unexpected input mode. Right, I mean, we know what this will show. No, I need to be in main. Load that, go here, main. $91 to $30 in int code. Here? I mean, I can fail here. It's fine. Why? Why am I expecting the destination? Okay, so here it's saying, oh, the destination of a binary is also not in position mode. Do I need to read the spec more carefully? I thought these parameters... I thought the parameters you write to couldn't be in a weird mode. But here's a second case where it seems like that's happening. Well, okay, let's like print out what it is at least, I guess. I guess just show actual is fine. Yeah, 40 immediate, 10 immediate, 10 relative base. Okay, I guess. I guess we just need to support this, but like previous one on 5. Existing computer. Saves it to this position given by its only parameter. Parameter modes. Parameters that an instruction writes to will never be in immediate mode. I see. At the time, I read that and internalized it as meaning they will always be in position mode, but that's not the case. They're allowed to be in relative base offset mode. I see. Okay. So write, I mean, it's taking an address and a value, but it could just take address and mode and value. Like we're calling write here and here. And these are the two cases where we care about yeah, like let's just take, I don't know. It's a little gross, isn't it? Wouldn't it be maybe better to just call make absolute up here? No, I don't know. It's kind of nice for write to take an address. No, I don't know. I don't like that. We'll just add it in here. So in run bin, we'll do kind of like the same thing here. This needs to be lifted out to a function somewhere. Make absolute of C param. I could just, it wants param in mode. I could just pass it the tuple, right? Computer and a address parameter mode returns a new address. C pause mode. Maybe it was called param mode, I think. Okay. So now make absolute up here is fine. And we just need to do it in run bin as well. Make absolute takes a computer Oh, the destination. I see. Wait. Read AC. So wait, isn't destination already like the pair that I want? Writes type. Oh, it takes a memory? Oh, update memory though. It takes a C. Okay. So what exactly are the params exactly? They're an instructions params. And instructions params are a list of values and modes. Oh, I have to say what I want to write. Okay, you got me there. It's a number. I love it when we get numbers, as has been previously discussed on this series. Oh, I'm like, what? This is day 5. Yeah, let's look at day 9. That's the right answer. Okay, well, I mean, it was not as smooth as I would have liked, especially considering it was just part 1. But we got through it. Let's look at part 2. You now have a complete encode computer. You just need to boost your sensors using the boost program. The program runs in sensor boost mode by providing the input instruction value 2. Oh. Once run, it will boost the sensors automatically, but it might take a few seconds to complete the operation on slower hardware. In sensor boost mode, it will output a single value. Interesting. I'm a little bit worried. Like, it's not like we implemented something at all efficient. Yeah, and it looks like I'm going to have to actually say... I guess it shouldn't be a surprise to me that the inputs changed between the types, the parts. So let's, I guess since this is going to be slow, let's I don't know what it's mad about here, actually. Let's type make computer. First a program, then a value. Oh, I didn't run to completion. Okay, so this type checks now. Let's run it compiled. Oh, that's not bad. Okay, well, I guess we have a complete working encode computer. That's nice. Yeah, surprise part 2 went so smoothly. I thought part 1 was just like the softball to get us like into the idea of what was coming up next, but I guess there was nothing left. Huh. Oh, I didn't commit. Whatever. Let's see. Git adds. Wait, what? Oh, I should have said no edit. Whatever. I guess I also want to add my input and do the same thing again. Day 9, part 2. We got everything in. Nothing left to commit. Okay, the video must be over then, right? Thanks for watching, and I'll see you next time.